Hello, welcome again. We are solving some questions of applied mechanics. The topic is collision. Question number 3 and 4 carries a common statement. The statement is a ball of mass 1 kg moving with a velocity of 2 meter per second impinges directly on a ball of mass 2 kg at rest. The first ball after impinging comes to rest. So question number 3 is the velocity of the second ball. Option A 2 meter per second, option B 1 meter per second, option C 3 meter per second, option D 1.5 meter per second. Question number 4, the coefficient of restitution. Option A 0.3, option B 0.5, option C 0.2 and option D 0.7. Okay, so here mass of first ball is 1 kg and second ball is 2 kg. Initial velocity of first ball is 2 meter per second and second ball is at rest. Okay, so from the conservation of momentum we can find out the final velocities of these balls. Okay, as the final velocity of first ball is given as 0 because it comes to rest after striking. The first ball after intervening comes to rest, so the final velocity of first ball is 0 and suppose v2 is the final velocity of second ball. Then by momentum conservation, so we can find out velocity v2, so that is initial momentum m1 u1 plus m2 u2 and that is final momentum m1 v1 plus m2 v2. So by putting with these values, u1 is your 2, u2 is your 0, m1 is 1, m2 is 2. So this is your 0 and this is your 2 into v1 or so 2 into v2 or v2 is your 1 meter per second. So final velocity is your final velocity of the second ball is 1 meter per second. So answer to question number 3 is B. Next question is coefficient of restitution. Suppose E is your coefficient of restitution, then the definition of is E is defined as the velocity of separation divided by velocity of approach, or we can say the how much there is decrease in relative velocity of the two bodies due to collision. Okay, so that is that is the definition of collision of elastic bodies. v2 minus v1 should be equal to E u1 minus u2. So that is the relative velocity initially and that is the relative velocity finally. So E represents the ratio of these velocities. So relative v2 we have find out that is 1 and v1 is just 0 and u1 is the initial velocity of u1 is 2 and final velocity is 0. So that is initial relative velocity and that is final relative velocity. So E comes out as 0.5. So answer is 0.5. Option B is the right answer.